Hey, hello, Ben Chung.
I'm
Hello.
Hi, David.
Hi,
How are
David.
you?
I'm good. I'm good.
Yeah, doing well, thank you. How are you?
Not bad. We haven't talked in a little bit around DAC and travel. So I'm kind of excited to be back looking into this cool CDX stuff. Let's see. Let's see. Let's give everybody maybe a couple more minutes to join. And we'll see. I don't have any information if anyone else may or may not join. So we'll see if we get a quorum or not. Given it's summertime, I kind of expect things to drop off here and there. So we'll see. Okay.
Yeah.
This time I wasn't at DAC because of two other things I had to attend, but I'm curious about whether OCP did things at DAC.
OCP did not do things at DAC. There was a discussion how to set it up. And I think there was a discussion with EE Times. I'm not sure if you noticed, EE Times had a little area allocated to them, and there were some presentations going on. I don't think OCP per se was represented, although there were some of the OCP members who were there, I believe.
Okay.
Yeah, DAC this year I found it to be a little bit smaller than what it was last year. I'm not sure what the official attendance numbers say. Which was a little bit different. Naturally, there was a lot of AI stuff in there about writing RTL, writing test benches, stuff like that. You you would expect that to be there. And then the usual suspects.
Okay. Yeah, thanks.
Yep. Hi, Bella.
Hi, everyone.
So Bella, I asked if I asked that Rajesh if he's able to join us today to have the discussion around test. I'm not sure if he will be able to make it after all. So maybe I was wondering, given that we kind of missed a few meetings, if there has been any developments since the last time we talked a little bit about test. And
yeah, so I mean, it's not much development. We had a couple of offline discussion with myself and Vikas. So we wanted to we identified set of things that we can prioritize for the TDK development. So that's what Vikas is putting together some document, and so we want to align with Tony and Pratyush and all the team's members, right? So basically, for the TDK, like what we are thinking is like we want to have this a way of like yearly assessment, doing the yearly assessment of this coverage to identify like a scan and boundary scan across the interdie. Is that covers everything, all the IOs across the interdie connectivity and also to the package. And so does that,
Okay.
is there any implementation gaps, and how do we identify and flag them earlier on in the multi-die design phase? So that is one aspect that we have found out, where because that this particular activity today, it happens based on the bottom-up approach, where people try to spend more than 95% of their schedules on the internal scan test coverage kind of things, but then they delay so much on the X test and inter-die coverage analysis kind of things because of high uh, huge size of the design and the models. So so we want to find out if there is a efficient way of modeling and creating this abstraction and flagging that coverage gaps, right? So that is one aspect that we have thought through. So for that, so we need the BSTL, and then we need some sort of modeling like a gray box and for the scan and IJTAG kind of stuff. And so that's what we wanted to work together to identify some test cases and that we can put together. So um, so this particular area itself, it's a lots of work, like where we can define a task across modeling and then coverage and then creating a different baby steps for the multi-die. Right. So how we can efficiently do as a top-down
Yeah.
approach.
Okay.
Right. So because
Yeah.
it's not affordable for the multi-day schedules to wait for the all the chiplets to models to be stabilized and then you start the coverage analysis, right? So but rather we can do some
Yes.
shortcuts and then pursue in a parallel track as a top-down approach of these efforts. So
Okay.
yes,
So thinking along those lines, you mentioned the test case. Do you have a test case, or do you want to use the design that Singmin is working on?
So yeah, so that is something. The open dot project has a test case based on the risk-free project, so that we can leverage it. And so Vikas has somebody in that channel, like so he is trying to find out the clarification, like if we can use that for the commercial purpose. Is there any licensing issues are there? So he is going to get that answer, and so we'll yeah. So we need some more time, and then we will come up with the entire plan. Like so, right now, I think to start with, we have everything what we need, and at least in terms of planning and coming up with the user spec, like a statement of work kind of documentation. So it's we have everything in our mind, and so we are starting to put together and review together, and then we like to present sometime sooner, maybe next occurrence of this
Okay.
meeting, right? So then we can get consensus from yeah, Tony is here. So I'll also offline work with Tony to get some more feedbacks and consolidate all the inputs. Right. So Tony also has a longer vision, like where he wants to stitch all the different flows and like a formal verification, constraint validation, things like that. So those also we can add into this list.
Okay. So in terms of TDK, can you give me some preview? What are you thinking? You mentioned some BSTL. Those are existing models, right? That kind of exist, may need to be provided or may need to be generated. What do you kind of expect to have at a chiplet level kind of black box definition that would be useful, right? When put in CDX about JEP30, that would be useful to the next level test integration, test insertion.
Right. So,
Did my
yeah.
yeah.
So the currently the BSTL and the scan, both of them achieve hybrid coverage for the interconnect test. Like so for the die-to-die test, there are a few portions which are covered through the scan testing itself, and then few things are covered through the boundary scan. And but boundary scan comes a bit later, wherein the segment BSTL defines what sort of IOs goes to the external to the SIP and what sort of IOs goes to the internal to the like a inter-die kind of connectivity, right? So, but then the package BSTL, which needs to be generated based on the need basis, like which mode that they are trying to target the test case. So based on that, the segment definition and the extraction of those sub-segment BSTLs and collaborating with the scan, because today the boundary scan structure can also get interleaved with the scan test, right? So which can hook up with the recent enhancements with the tool EDA tools also, like so we can use the boundary scan chains as part of the sub scan chains, right? So all these things put together, it forms very convoluted problem statement for the DFT owners to create the test case and then partition them across the different coverage buckets, right? And then analyzing the coverage buckets also it's tedious. So we have different tools are involved, and fault grading them. It's also a lengthy process, like where we have the high load on the model. And so that's where we want to define a set of baby steps and do a top-down approach, like breaking them. And these are the must to have. And like once you achieve these set of things and fault grade it, and then you have this, if there is any coverage gaps, and then that could be because of the implementation gap or because of the oversight with how we differentiate the modes. And did we forget to fault grade some sub modes? Some sub modes are not planned or not coded properly in the implementation cycle, right? So those details that we want to iron it out and drive as a top-down flow rather than waiting for the bottom-up flow to come as a last activity, right?
Yeah.
So yeah, we have that track.
Right. Sorry, I think I interrupted you. Are you focusing on whether we are talking about disintegration? Sorry, disaggregation into chiplets or integration of really chiplets? Do you is your current thinking biased one way or the other?
Yeah, it is actually, it comes into both the buckets, right? Today, like involving all the chiplets, it is much more needed to cover all the IOs, interconnected IOs, because that it gives that extra coverage for the SIP or the stack level DFT.
Yeah. Okay.
Right. So yeah,
Okay.
yeah. So yes, we cannot subdivide, like we are not going deep down into the chiplets to define like how the interpartition coverage, things like that, right? So that is into the chiplet. So we are looking at the chiplet IOs which are interconnected, and so trying to cover the all the wires which are interconnecting the chiplets at the stack level.
Yes. Okay.
Yeah, so I think that's a long poll, which was never been done by the DFT folks ahead of the time because of the schedule and bandwidth availability and getting the maturity of that in-test coverage, and then achieve the top of coverage for the X-test. So that's where people like miss the schedule. And so like having this like EDA enhancements and driving the top-down flow, identifying the gray box black boxes scenarios, and identifying the baby steps, and showing the list of modes and how you have to fault grade. And so all these
Yeah.
things are very complex, and yeah, so which needs help across the DFT team
Yes.
in a bigger companies.
Yeah.
So I believe
Yes.
yeah, this is one area where which will also attract like moving down the line, we can leverage the ball map file from the 3D blocks for the placement aware UDFM based coverage like ATPG, like a transition ATPG test
Yeah.
for the to stress the high dense interfaces. And also we can leverage STC, UPF, the right number of things that we can leverage, and then create some static rule checks and help little bit on the chip installation sequence, where which is also dissected because of the power of sequence is complicated when you want to interleave between the dies, right? So
Yeah.
with a higher scale like a NAPMP deserves, like so we need some static rules to make sure that the power switches are alive for the pertaining um, targeted test data paths, right? So all those things are
Yeah.
done today in the simulation, like with a power hour kind of simulation. Those type of models are not available, are not going to be available for the multi-die kind of models, right? The power
Yeah.
awareness and or even timing GLS. So those are not going to be available for the multi-die within the schedules. So so having some static rule check as an extension of this work on this area will definitely help. But we do not want to like explore the list and not able to complete with within our timeline. So we want to
Yeah.
start with the modeling and then coverage as a top-down approach, and then add this extension of the second phase.
Yes. Okay. Yeah, that makes sense. Are the other EDA companies involved in these discussions? The all the relevant companies that do DFT test insertion and stuff.
Um, yeah, every company has their own flows. Like Rajesh is here, like he can comment on this, like how Karen's planned.
Yeah, no, what I'm trying to understand is, will this be this top-down flow kind of work with all the tool vendors at the end of the day?
Yeah, so the today there are mechanisms to achieve this, like so top-down flow is pretty much supported across all the tool flows, but it's how the DFT team or the design management, how they plan it, right, with the manufacturing, right? So manufacturing always puts a pressure to get maximum pattern as possible and put it into the test floor. So that's where people run and attack all the internal test coverage related stuff. And so the X-test is always is the last criteria for the towards the meeting the coverage goal and the DPPM goals. Like that's where people keep adding those additional tests, right? But that it leaves some coverage gaps or implementation gaps. That's a worry to the project, right? That's a risk to the project where this type of having an advancement on the top-down flow, like um, with identifying with an automation set of utility scripts with having some baby steps, right? So all those things will play a crucial role, like to pull in the schedule for these activities.
Yeah. Okay. Okay, good. That's good. So the the way I understood your comment is this is really kind of not really going into the different EDA companies. Test insertion flow is mostly on the user side, integrating everything together.
Right,
Did
right.
I get it right?
Yeah,
Okay.
yeah.
Okay.
Yeah,
Yeah, that's good.
yeah. There are some gaps, like as we discussed in the earlier meetings, like the um, IO pad controls which are not made visible to the test insertion flows because of the lack of use and the lack of EDA support. So that's a totally
Mhm.
different problem statement. So I don't know like how much we can touch that into this plan. So I need to
Yeah.
still consult with Vikas and then see on the NGMM side, like what they are on that project, what they are adding more values, right? So we can appropriately we can prioritize it, right? So because the IO pad, um, how that the picture looks with the 1838 integration scheme, right? That's also I did presented a month before. Yeah, Vikas is aware of those details. So, but to get into
Yeah.
reality, like what we have as a database and things like that. So the uh, attacking the excess kind of scenarios is more logistically feasible compared to the um, and attacking this pad control stuffs, right? Which needs much more collaboration involvement with like a technology development from foundries and supporting the DFT views, like creating a new DFT views for the IO pads, right? So complex IO pad controls um, are not supported by the EDA tools, so we might need some enhancement from the EDA tools as well, right? So that
Okay.
itself IO pad control into something into the test program, and that it needs lots of blessings from multiple stakeholders. It's a long project.
Uh, Sorry, that's my I don't know. When you mentioned IOPAT control, what does that mean?
So
When
today the DFT insertion this happens at the logical hierarchy, right? And then the patterning is built on top of it at the chiplet level,
okay, yes,
right? So DFT tools and collaterals doesn't know what are these patterns and how it has to be controlled, right? So
okay,
every
yeah,
company,
okay, yeah,
yeah, every chip design company, they have their own internal chip build kind of tools or some partition tools. They add this patterning structure and drive some controls through the internal AXI registers and for the firmware purpose, and then JTAG
yeah,
registers through for the test purpose,
I see.
and then they give a documentation for the test team, like, so these are the default values, and then these are the instruction and the register set, and after the different data bit fields. So you can reprogram it if you find any shortfalls in your test screening, right? So, but creating some DFT models for them, like so IO pads can be seamlessly inserted as part of the DFT insertion, like for example, boundary scan insertion uh, or or design wrapper register creation steps. Like so, those tools can easily intercept and then add these controls and hook up those JTAG registers as part of the equal description, which tools can understand, and people can on the fly create PDLs and program that through the test infrastructure, right? That so all those features are not available today. So people go through this manual in setting up this additional pad control sequence wherever they see shortfalls, and they need to configure yeah, different drive strength or time delay values, like override the default values. So
Yeah,
they kind of manually hack the patterns and um, uh, do that experiment and then put it into the final program, right? So that all those manual efforts we can help if we have a single set of IO library models for the DFT views, right? So which
yes.
yeah, which can be easily derived based on the simulation results, things like that. But but nobody supports it today. Like so, there are many. I spoke to many library vendors in the TSMC symposium as well as Samsung Safe event. So there are many third-party library owners, like they create some custom libraries, IO libraries, um, like standard cells and memories, and they see this as a workable solution because their simulation regression results, like they have everything that what we needed. So it's just that one automation layer needs to come in and create this extra views.
Yes. Okay. Yeah, I think I get it now. Thank you for the explanation. Yeah, this sounds like a complicated one.
Yeah.
So and yeah, so at the end of the day, um, um, say when you have all the models and everything, do you expect that a vendor writing a chiplet would also have to give you the IO views, or all of that can be abstracted out without providing you the actual IO library?
Yeah, that's a problem statement today, right? Where the IO views are not available, like, but the yield assist kind of tools, like they have the GDS views, and they kind of identify the location of the faults from where it arises, and then from there only it comes back as a debug data finding, right? So, but having so all those things can be easily mitigated if you have these views, and then you can um, incorporate that as part of your simulation criteria, other things. So right now, at least for the these problems can easily get overlooked in terms of multi-day scenarios where people doesn't do any timing simulations today, right? At the multi-day with these
Yeah,
pads,
yeah,
right?
yeah,
So it's only RTL simulations. That's what they have a capability, and then minimal baby steps at the multi-day.
yeah,
Yeah. So
yeah.
yeah.
Yeah, the what I'm trying to get to is a situation where if say I have designed my chiplet using TSMC libraries
Mhm,
and I want to sell that chiplet, right?
mhm.
Now, when I'm selling that chiplet, do I have to give that customer the TSMC libraries also, right?
Um, yeah, for the diagnostics, I think they would need it, right? So without like diagnosis tools, just with the raw GDS, they won't be able to work on this, right? So, because the image, the flat model kind of images that they get it from the DFT team, which works with the GDS, and the flat model will internally abstract all those model stuff. Right. So
Yeah,
you
yeah,
the,
yeah. Basically, I guess my question is my actually it's not a question. It's a concern kind of question, right? If I have to ship any TSMC data with my chiplet, that's a very complicated business process, right?
right. Yeah.
So I guess the question then is: are any models being shipped with the chiplet abstracted enough such that they do not require TSMC to
Okay.
be
So
involved in this?
okay, let me put this question other way around, right? So where when people are giving the chiplet and it goes to the multi-die, right? So at the multi-die level, when they do the package integration and check the timings, like do they treat these models as a black box, or do they need IOs also? I mean, do they need the libraries? I believe a package team would need those libraries, I believe.
Not for the only place where this may be needed is any models for the die-to-die interface, right? For example, IBIS model.
Mm-hmm.
Right. So whoever is supplying that, their IBIS model probably needs to go off with that. But that's still not the a library cell, right? It's still a abstraction, although
Yeah,
some stuff can be seen, right? It's still quite a bit of abstraction, right? And
right. Yeah.
You can but right, it's one thing. It's another thing if I have to give my customer also the Liberty file for the ISL for TSMC. Right.
Mm-hmm.
Now that gets complicated.
Right. Yeah, that is true. So I believe the flat model, from the DFT standpoint, I think the flat model achieves everything what we need, right? Because it has the abstraction of the netlist and the libraries. And so we don't have to like separately give the libraries, but the flat model and the patents, the entire patent database is good enough for any of the DFT debugs or the yield,
Okay.
right, kind of yield assist kind of tools. Yeah, we don't need dedicated libraries.
Okay. Yeah, that's good. What is let me ask the question like this. How much of the test insertion is done at the RTL level today?
So except the scan injection, everything is feasible with RTL today. So all the PTAP, STAP, like the 1838 components, and the SIPs, all the IJTAC network, then the memory based and OCCs, on-chip clock gating stuff, and EDT, like compression engines. So everything is done through the RTL today.
Okay.
Yeah. So
And
only the scan
scan.
only the scan insertion it goes post netlist, right? So because you need the actual flip flops inferred and then want to switch them. Right?
Okay. How about on the simulation side? And what I mean by this is here's what I have in mind when I'm talking about simulation, right? The other work streams at OCP are talking about how do we when we have two chiplets, right? I get a chiplet from vendor A and I get a chiplet from vendor B. How do I know that all both will work together, right? There's a lot of complexities around right, that you start with electricals, right, the electrical interfaces, and then you talk about the next levels of protocol, right? Make sure that they're all compatible and then that they can actually talk to each other, right? And there's a lot of things around that. But part of this is, I guess, Okay, I have say that the other work streams have solved the problem of that functionally they can ensure that two chiplets can talk to each other somehow. Now, the next question, right, that's relevant to this discussion is, how do I know that I can that my test is going to work, right? And that the way, right, probably early checking is easier, right? Just sanity checking that, okay, these two chiplets can be hooked up correctly, right? It is that is possible to be hooked up correctly, right? That they're compatible.
Right.
But then I guess a more complicated problem is ensuring that they're actually correctly connected and everything. So in that context, right, if I'm doing test insertion at the chiplet level, I would run simulations. Right, and I can show that it works. Am I expected to run? I guess I'm expected to run simulations on the entire SIP that all the test insertion and hookup actually worked. So I would be expected to be able to simulate the other guy's chiplet pretty much in full, no? Or at least right. In full, I mean, right, the test related stuff.
So yeah, so the only complexity that we have today is like so there is no EDA agnostic tool to handle two different EDA vendors patterns or compacting them or post processing or remapping or retargeting them, right? So right now, uh, I don't think any company that they are doing it today, like to trying to integrate two different chiplets of from two different EDA vendors. Even if they provide it, they just give the raw access mechanisms, direct access mechanisms to those chiplets for the final test, like with a minimal padding, right? So having some latency cycles because of some pipelines getting added uh, when we DC chain the tap or the parallel interfaces, like a SSN kind of parallel interfaces for the scan, right? So because those are the handling the pipeline and the throughput latency, those can be achieved by creating a wrapper level, like a stack level equal abstraction, and like tools supports the equal, and the semantics is common across the EDA vendors for the equal standpoint, where like to infer program any additional mux, scan muxing or adding some latency pipelines in the input or output pipelines. So the tool can theoretically they can infer those latencies but when it gets exposed through the additional equal and retarget those patterns right as a theoretical method. But we need to expose test cases and then see if we are really having some bottleneck where a tool doesn't support it, right? So we have some of the corner cases are like the tools today, they create the pattern database in their own internal proprietary format, right? Those pattern database are getting replaced for the scan for the retargeting at the upstream, right? And so those cases are definitely a corner cases where the pattern TB database is not compatible with competitor tools, right? But there are scenarios where they just write out the style patterns and then read the style patterns and then retarget it, and that may be doable. Like yes, it's like a in the entire style written out at one block hierarchy. It's kind of a style RPDL. It should be as long as it's IEEE standard and there's no hacks within the tools, and so they should be able to support it. But um, we need to have test cases to demonstrate those are doable.
Yes.
Right. But the baby steps
Yeah.
for the to give an answer for the baby steps, people hand create some Verilog test bench and our UVM task, and they prove that access mechanism works, right? So you don't have to reinvent the wheel to retarget the existing patterns and then prove that pattern to be working, right? Those are more software
Yeah.
problems.
Okay.
David,
Yes.
may I ask a question about a topic you were pursuing a few minutes ago?
Sure. Yeah.
Uh, Okay, right. You were asking about whether for test we would, a chiplet would need to include information about TSMC models if it used TSMC for its manufacture, for its fabrication. And so I was looking back through a presentation from OCP about chiplet design kits, and it describes different contents of a design kit. And that presentation says that for for SI analysis, that optionally a chiplet can include a SPICE netlist for IO driver and receiver. So if it did that, then I guess that would also require TSMC models or whatever fabrication models were used for those library cells in that net list. And is that right?
Um,
Actually, you want to cover that, David, or?
yeah, go ahead, Tony, and I'll answer. Let's see how much we are in agreement.
So generally, any IP vendor is not going to give a SPICE net list of the actual buffer or transceiver. But typically, what's done is they can provide a kind of a representative model of just the output buffer, which is, ultimately, I don't think it's going to have any proprietary SPICE type data. The normal deliverable is an IBIS model, which is basically a table lookup model. And generally, you could even create a table lookup model with a representative model of just the transceiver. You could develop that maybe using the TSMC SPICE cells and then create an IBIS model to kind of obfuscate the details of the process file. So that's one approach you could use.
Yeah.
Okay, I see.
Yeah, exactly. I was going to say the same thing. It's basically, think of it as effective SPICE model, right? It's a circuit that behaves the same way as the IO, but without giving you the process details. We give the circuit internals, right?
That makes sense. That makes sense. And so then you were asking whether for test we could do this. Essentially, can we do the same thing, or do we run into any situations where we would need any of the TSMC actual data?
Right.
Okay. I see. Thank you.
Yeah. One thing that I realize is happening is we wrote that that CDK. What is it, Tony? Like 2-3 years ago, right? And the overall thinking about chiplets, I guess, is actually evolving. Back then, I don't think there was anybody working on off-the-shelf chiplet. Today, there's a lot of people working on off-the-shelf chiplet, and these questions kind of come up, right? What do I have to ship, right? And if I have to ship TSMC data, that makes my business very, very difficult, right? Because for every of my customers, I have to do three-way NDA with TSMC, convince them to share that data, and it gets really complicated.
Yeah. Yeah, makes sense. Okay.
Right. Yeah, and that's why if there's a way to abstract it out in a way where me as a vendor of the chiplet can determine that I do not have any of my vendors' data in that, and on the only data I'm shipping is my data, then I can. It becomes easier to control from a business point of view, right? Whether NDAs and things like that are sufficient, right?
Right.
Obviously,
And-
you know, nobody is gonna give you the chiplet and completely open their IBIS model, right? Because that's also proprietary, right? You can determine what the source does.
right. I mean, I guess it's similar to hard IP vendors, right? A hard IP vendor for that's providing something that could be used within an SoC. They wouldn't provide, they wouldn't provide the specific.
Typically, they would provide an IBIS model, which is kind of again obfuscating any technology specific stuff.
Right.
Yeah.
Okay.
But yeah, the only
That's the
difference for hard
preferred
IP,
deliverable. Yeah.
yeah, the only difference for hard IP is both parties will be integrating onto the same process, and they need to have already access to that same process, right? So that makes it very easy, right? Even if I have to ship spice, my spice would reference the TSMC model without me having to ship the TSMC model, because the other party already must have the TSMC model anyway
yeah.
for their work, right?
Right. Okay.
And in that case, I'm responsible only for my circuit design, right? And that's my IP.
Yeah. Okay.
And with chiplet, it gets a little bit tricky because hopefully there's going to be more than one big vendor of silicon right? How do you integrate it then?
Yeah. Okay.
Yeah, that's the part of the thinking that's evolving, is that right, the business side. What does it mean to make chiplets work together? And I don't know if there's a good solution to that. Yeah, the other work streams at OCP are trying to figure out a way to quickly prototype with chiplets. They have some ideas that right there again, everybody first question it, right? You want to make sure that functionality works and performance works. So they were thinking about using system C models. The only problem with that is, at least for me, I consider that a system C model to be even more proprietary than a RTL, right? Because system C, I can much easier enhance and spin up a new design, right, than RTL.
It would be a functional model, not a structural model.
Well, yeah, I don't know what they're thinking. And the other side of this is, I don't think anybody has a system C model for their entire SoC. I don't know. Do you guys know?
Say again?
Does anybody have a system C model for the entire SoC?
Oh, I mean, ARM has models. Yeah, so processor type vendors typically provide high level models.
So they will provide a transaction level
Yeah.
ARM CPU model, not the cycle accurate system C model.
Correct.
Okay.
Yeah.
Okay.
And yeah,
Yeah,
if
that's
you license their IP, you can get access to those more detailed models. But if you're just looking, for system level simulations, that's probably what they would provide.
okay.
Yeah.
Tony,
They would put that in the CDK in an open library is a different story. But
Yeah.
We basically you know, the only models that are required in the CDK are the JEP30, the P101, and the E101. All the other models are recommended, and it's up to the discretion of the chiplet provider what models they would include in the model. We have a checklist that at least will summarize what models are available, and they can either be delivered through, in the JET model, in like a catalog, or you want, once you procure the IP, then however they choose to deliver that is up to them. JEP30 is a vehicle to do that, but it's not required. I mean, they could still do it the way they normally do it with secure OCP sites and such.
Yeah. Tony, do you know if, just in general, if a transaction level model for a CPU would need the code to run, would need a code to run to get the model running, or there can be, how do I say, abstracted level of simulating what this model does somehow?
You mean, can it run code, software?
I mean, not can it, but does it have to run code?
I don't know.
Okay.
I would think so.
Okay.
Otherwise, what are you gonna do with it?
Yeah, I don't know, right? Then that makes prototyping with
So the
system sim
functionality
models.
of a processor is to run code, right? So if you don't model that,
Yeah.
that would be like modeling an ADD converter, but you can't model what it does with the data.
Yeah.
But it might depend upon what you're trying to do, right? For some of the things you might want to do, if you have a bus functional model of the processor, because you're just trying to test the bus interface connection between it and something else, then maybe just having the bus functional model is good enough for some things.
Yeah. So those are all kind of options that we included in the CDK. You need some kind of functional model, right? So BFMs, cycle accurate, full synthesizable obfuscated models. I mean, these are just recommendations, right? It's not really all these things exist today. There's nothing new or defining, so it's just a recommended deliverable, and there's many forms that deliverable can be manifested. So we kind of leave that up to the discretion of the IP vendor, the chiplet IP vendor.
Yeah, I'm trying to understand, right? When we're talking about prototyping with chiplets, is if I have a choice of two accelerators, right, from two different vendors, and I have my own CPU chiplet. Now, when I say I'm prototyping, do I have to develop some software before I can kind of gauge whether the chiplets are going to work together and perform the way I expect them to perform, or can I even do that estimation before that? Right? If I have to go and develop the software around this becomes very I don't know. Prototyping is I'm not sure if it's the right word, right? It's
I can
already
tell you
implementation.
what most of all of the three major EDA vendors do. They provide hardware emulation. Well, actually, Cadence and Synopsys do hardware software co-simulations. I don't think Cadence does that. They just do hardware simulation. So, they are using hardware optimized models for the processors, and so they run at probably 10x real time. So you can actually do software development and run it on the actual CPU.
Yeah.
But in a traditional simulator, you'd be 100 times slower, so it becomes not really practical to do software debug in your system. So that's you really need that hardware software, hardware accelerated verification environment. So Synopsys and Siemens are the two primary vendors that offer that.
Okay. Okay.
In fact, if you went to DAC, did you go to DAC this year, David?
I did.
I missed you. I was there, but we had did you see the car in the Siemens booth?
I don't remember.
Well, you would remember. It's a real car.
Well, I'm confusing my memories because usually, who was that guy? Dean Darko used to show some sports car,
Yeah.
a McLaren or something like that.
Yeah, I forget what kind of car it was, but what they have is they have a complete digital twin model of the car, running on running actual software workloads from driving the vehicle, including all the video displays of that coming from the cameras, and that's running on an emulator over the cloud. So the thing is sitting in the back trunk, and you could sit in the car and you could actually see it, turning the wheel and stuff. They did disable the drivetrain, obviously, because they don't want to get too carried away.
Yeah.
But it's pretty impressive. I mean, it's
Yeah.
you see objects, coming up. So it's the autonomous driving, software. It's actually running in almost real time. It looks like you're driving, 10 miles an hour, but still you're seeing. It's pretty cool. So it's just shows you, what we can do these days.
And that's okay.
But that was tight collaboration. Those models were optimized specifically for our compiled into our hardware, and they're all protected. And they did similar things with Synopsys. So
Yeah.
that's what for big processor type things people are doing.
Okay. Interesting.
So we did a panel also on software-driven hardware. So, it used to be you would write software that runs on your computer. Now you're writing software and designing a computer that's optimized to run on that.
Yeah.
Yeah, so David, you were asking about what kind of prototyping you can do without having an actual instruction stream or something.
Yeah.
An actual simulated model. There may be some things you can do at a higher level. I mean, people talk about virtual platforms and transaction level modeling, and I don't remember the names, but I understand there are some companies that are their business is to help teams that want to do system level modeling. And so modeling at that higher level of abstraction, you may be able to make some initial choices. And then, like Tony said, then you'd want to get into the real instruction level modeling and then to validate those initial findings. But you may make some initial findings at a higher level.
Yeah. Okay. Yeah, would be, yeah. I think yeah, okay. Yeah, I think the business works team is kind of on the right path. We'll see how we can support them if something comes our way. So I'll swing by if you guys want to swing by the business works team, see what they're doing and asking. Please feel free to do so. I'll probably swing by and monitor what is it that they're thinking. Yeah. Okay. Good discussion today. We are at the top of the hour. So we'll resume the test topic in 2 weeks. Next week is SIPI. We'll get that going again, and we'll try to finalize the spec.
Okay, cool.
All right. Okay, everyone. Thank you very much,
Okay.
and talk to you next week.
Thank you.
Okay, thank you.
Bye.